Yes, hello to our statistics course, and today we want to do a little case study I already announced last week. And yeah, within this case study, we want to make a forecast for inflation based on the dynamics of oil prices. So we make a guess where the oil prices will be in the next year. And this guess we want to feed into the total aggregate of inflation, so the consumer price index. And of course, energy or oil is not 100% of the development of consumer price indices. And therefore, we want to calculate the historical dependence between the oil price and the energy component, which is mostly oil, and also gas prices are highly connected to oil prices, of course. And therefore, we want to calculate via linear regression the dependence between the energy component of the consumer price index. And then, yeah, so to speak, we want to make a forecast then based on what we think where are the oil prices next year. And then we say, what is the part of inflation just coming from this development of the oil prices? So we assume that all other prices stay the same, are at the same level as today. And yeah, for this, I don't want to give you just the numbers and then we make the linear regression and so we are done. But we want to make also the process of how do we find the data together today. So maybe you have already thought about it. So we will do this, of course, this then in Excel. And therefore, at first, we need the oil price, and let's take the oil prices, the development of oil prices over the last 5 years. So have you thought about how to obtain the oil price of the last 5 years? First of all, we have to think about, what is the oil price? Because actually there is not that oil price. Because why? This we are discussing today. Think about the oil production or the gasoline production around Berlin. There we have our industry complex, and this industry complex can only use up to now the oil which is coming from Russia. So, of course, we have different kinds of specific oils, and they are different. And so we have to think about, if we are talking about that oil price, then what would be the general oil where we are looking at in Europe. And for this, we have in general, more or less two most important oils in the world. And one of these oils is the WTI, West Texas. This is maybe the most important oil price for the United States. And then we have the oil Brent, and this is in general the oil which is coming from the North Sea, and this is more or less the benchmark oil price for Europe. And yeah, how do we get these oil prices? And there you have to go into the data and you have to think about where can I get the data. And yeah, one really good source for macroeconomic data is the so-called FRED, Federal Reserve Economic Data from the Fed in St. Louis. And this is where you can find many data series which you need in economics. And so we are just look for this. Let's take this also as a link here. So link for oil price of sort Brent. So hopefully this will work. We just go in here, Brent oil price, crude oil price Brent, and here you see for Europe, and we click on this, and here we are. So this is the oil price here from 2017. So we want to have the last 5 years, then let's take from 2015 until today. And what you see here is we have the frequency daily, but we want to have the frequency of monthly, so we can change here to monthly, and then we have the monthly data over the last 5 years, and therefore we are done for this, and we can just download it. Download the data and exercise, let's say case study. Oil, and this is Brent oil price. So, what else do we need? Well, for Germany, of course, the relevance of the oil price, which is feeding into our consumer prices. This is, of course, not the oil price in US dollar, but this is the oil price then converted by the exchange rate in euro. So for this, we have to convert US dollar in euro, and so we need the monthly exchange rate for US dollar and euro. And where can I get exchange rates? Well, I will also show you different sources. Of course, we get here from this database also the exchange rate, but let's switch to the German National Bank. So, of course, the national banks are also quite good sources for economic data, of course. Oops, I mean, this we don't need. And This is then statistics. And this is too small. So here, yeah, you see it. Exchange rates. And time series, exchange rates, and we want to have average monthly exchange rates. And then we have here United States should be then in the end. Here, United States. And we just download also the exchange rate, US dollar and euro. So what else do we need? Let's also take here the link. Up. Link exchange rate US dollar and euro. So what else? Of course, we need the time development of consumer price indices, and therefore the harmonized consumer price index. And where do you think can I find this time series? Do you have an idea? Well, there you have, of course, the General Statistics Office of Europe, and this is Eurostat. They are situated in Luxembourg. And here we are. Eurostat. Let's take also the link HCPI. So, and now here we are. Data. Of course, economics, prices, and harmonized consumer price indices and monthly data. Total. Why don't we see anything here? Is it too small? Oh, here we are. You see this almost. Then go in here. So this is your data. What do we need? We need the total consumer price index for Germany and the energy component. So here you see we have marked the total, and then scrolling down, energy, these are also all these single ones, and then you have here energy, country, we only want Germany. And time, of course, 21. And let's also go down to 2015. Download. And this is HCPI total and energy. So, and now we have all our data. Let's save this also as is it case study data? And then let's start. First of all, the oil price. Area. Oops. There's exercise, case study, and oil price. So we start here at May. Then let's start here at January 2016. Up, wrong, copy and paste. So this is oil price, Brent in US dollar. So the next one we need US dollar euro, the exchange rate. This we have here. So here we start from 1999, of course, and we want to start January 2016. This is our exchange rate. What else? The HCPI energy and HCPI total. HCPI energy and total. So this is the total one, and we want to start with 2016 January. So this one, and this we have to transpose only numbers, and oh, this was total and the energy component. Let's move this onto here. You see this? Yeah. Energy also starting 2016 January. and also transpone. And then, of course, we have to know the weight of the energy component, and this I looked up. This was 0. This is almost 9. This is around 90%, 0.9026, and therefore the weight here is 1 minus 0.926. So, what do we need right now? Until now, we need the oil price. This is US dollar, and this is the exchange rate. So we have to calculate the oil price in euro. Oil price in euros. What do we have to do? Then we have to divide this number by the exchange rate. Divided by, this is E, is not rho, is C. It has to be. So then you see here we have for the HCPI only data until March. So, and what we want to know now is the dependence between the energy component and the oil price in the last 5 years, or so to speak, when we start, or a bit more than 5 years, starting in 2016 in January. So then let's just move this also down here, copy, and paste. Then just have a look at the data. So this is oil price on energy, but we want to have it the other way around. So then let's interchange. No, this was not good. Then let's just move this here. Because then we are a bit faster in showing the diagram. Showing the data, and now we have, oops, why is it 100 here? This shouldn't be the case. Data is this is F and G. Okay. Let's have a look. data is F is X. This is energy, and oil price is Y. Oh, sorry. Again, we have to change this. Or let's do it like this. So then here a G and here a G. And let's take this F and F. So we have here HCPI energy, and here we have the oil price. Well, and now we want to make the linear regression, and this I showed you the last time. So we can just click in the data, fitting linearly and showing the formula. And there we have 0.5 roughly plus x plus 76 with an R squared of roughly 70%, and that is not too bad in the correlation. So, and these numbers we want to use for our forecast. So let's take here A is 76.415 and the slope B is 0.4987. So, and now you have to make a guess together, or we have to make together a guess where will be the oil price in the future in US dollar, and we have also to make a guess what will be the exchange rate in the future. So what do you think? So, oh, the chat is over there. Hoppala. They started, yes, this was also a good guess. There you can, of course, also find the data. So I just take the chat to the other monitor that we can communicate. So what do you think? What is the oil price today? Let's look this up. Brent is 111. What do you think? Where is the oil price moving in the future? Well, what are we doing the next time? There will be, with very high probability, an embargo of European countries. US, they have already an embargo against importing Russian oil. So I think this would be a point that oil prices will go up. So maybe then we can say that, oops, oil prices maybe will be 130 in the future. Okay? This is just a guess. You have, of course, make for your framework some guesses if you make a forecast. So then let's say in May we have maybe roughly 110, and from May on then 120 and 130, and this 130 we make the guess that this stays the same during the whole next year. So then we have to do this, and let's change to 2022, and we also want to have the forecast for 2023. Okay, and this he hasn't taken. And up 21 and 22. $130. So of course, again, we need the oil price in euros. So we also have to make a guess what is the development of the exchange rate in the future. And if you have a look at the history the last months, then we have a depreciation of exchange rate the last month. And what is maybe the reason for this, that we have a depreciation in the last month? This can be, of course, the reason could be that the interest rates in the United States, they go up. Maybe we will see also a rise in interest rates in the next month in Europe, but the interest rates are increasing much faster in the United States, and therefore capital moves from Europe to the United States because you have higher interest rates. And this, of course, will lead to a depreciation of the euro, and therefore maybe we can say that we move near to the parity. So then let's think about that we are going down, let's say for 0.05, 1.25, and maybe then parity in summer. With this, we can then calculate the oil price in euros for the next year. And oil price was the last column. So then we are going down here. And for this we have our oil price in euros. And now what we want is, oh sorry, here we have the wrong time series because we do not need the HCPI total, but the HCPI without energy. This we have to change. Okay, so let's go back. Data. Again. And we need not total, but also non-energy. And this will be also down here. Oh, I put it here that you can see it. HCPI energy, and here HCPI without energy, because there we want to make the assumption that these prices are staying constant. And total non-energy and energy, of course, non-energy and energy. Yep. Where is it? Total energy, non-energy. So this is energy, and here we have without energy starting from 2016. But I think you still see me. I hope so. So within our data and HCPI total, putting in the data, we have again to transpose the data, and here we are. So our assumption was that the non-energy component stay the same. The next year, because we just want to calculate what is the impact of the oil price on energy price, on total inflation. So, and now with our linear regression, we have the dependence that the energy component is 76.415 plus 0.4987. So what we do is that we calculate that this is oil price, is 76, and here we need two $signs because this has to be fixed, plus B, also fixed, times the actual oil price in March, in April, and this we calculate until the end, and then we obtain the total HCPI and here we also put in from our data total HCPI starting from 2016. Oops. Up. That this one is just the weighted average of energy component times the weight, also fix it, plus non-energy. Where did I have the non-energy? This was oops. I cannot see where I have the energy and none. So this is energy. This is HCPI, not total, but HCPI non-energy. So HCPI total is then non-energy times the weight and energy, which we have calculated, also times the weight. So we obtain is non-energy times weight plus, this is the wrong way, this is non-energy, so we need E and plus energy times D. And then we move this down here. And so we obtain equals average for 2023 is of course here the same. Up, not Mittelwert. And for 22, there we have to stay here. This is this one. And then this over this minus 1. So we could then say that as percent, oh, where is it? Up here. Oh, percent. So then we can say that more or less around half a percentage point of inflation will come from the oil price movement for the next year. So, and what I wanted to show you in this case study is that you once know that you quite often have to use the data from different databases. So you have different formats and how to get this data and how to put it in your software package. And this is also quite often not just a trivial thing. So then we can say in the result, result, first of all, dependence between oil prices and energy component HCPI. This was HCPI energy equals, and what did we have? 7415 plus 0.49 times oil price, and of course in euros. And then with the assumption that exchange rates US dollar euro will be at 1-to-1 in summer, and oil prices will be at 130 US dollar per barrel in summer until December 2023. We obtain that oil prices will move up inflations by roughly 0.5 percentage points. Okay, and then you go on, and then of course you say, well, if oil prices go up, then of course not only the energy component goes up, but also goods which are dependent on the transportation sector will also go up, and there you can also make your assumptions. What is there the dependence? You can also fit this dependence via a linear regression, and so on and so on and so on. And with this, then you come to something like an inflation forecast where you also take these second and third order effects in your calculations. Okay, then I will stop for today.